Today, I'm going to be talking to you about how you can use modern open source data tools to build with near to the open data. The reason why I'll be showing you this is because the tooling we have today is unlike anything we've had before, and it really allows us to have a new way of really using this data to really make use for our city. I'm going to be going over some of the apps I've already built and what you can use today. Then I'll be going over some of the underlying details and concepts that make up the apps and why they're important. And then I'll be going over some examples of how we can actually build a live pipeline during this presentation, and then going over the future and how we can build on this. Cool. So starting off with two apps, QueryStation.app and NYCStats.app, which you can see in the attached to the intro for this video call. And QueryStation is designed as a browser-based data explorer, so you can go in and be able to explore your data, query it all in your browser. Whereas NYCStats.app is designed as aggregated dashboards, so you can go in and understand your city. So I'm just going to jump right in and show them. So everyone can see this okay? So this is QueryStation.app. So right now, I need to have a little, we're going to do that later. So right now it's going to use local mode only, which means this is all running in your browser with DuckDB WASM, which means if I had private data, for example, I want to explore it, I don't have to send it anywhere. It stays in my laptop. So I upload this NYC 301 data sets ones already, so it allows you to do that. So let's say you want to upload data to be able to filter. So I only want to see HPD data sets. Okay. That are only electric related. Okay, great. And then be able to go up and let's say I want to actually explore with a SQL editor. So you can actually then explore with SQL, which allows you to have more innovative ways of going at it as opposed to just simple filtering and going that. Let's say you want to be able to explore a map. So we have NYC inspections, which allows us to actually go in and just by using the latitude and longitude columns, we can actually go in and explore. So it'll take a little longer for there. Great. So the main point, and then a little bit of notebook experience. So the main point of this is without anyone having to pay for any money, this doesn't cost me anything to host on the WASM mode. Anyone can now work with millions of rows of data. There's no excuse. It doesn't require any coding experience or anything to set up. You can just upload the file, export it all out. Great. Now, NYC is more of a query look at it, where I'm actually taking the end data sets and we're going to explore it. So this will look, let's start with NYC 301 actually. So the goal here is to create a centralized place where people can go in and explore different data sets and be able to drill down and filter it. So this is hooked up for the NYC 301 data set, a few days out, but for the less mostly accurate. So the map allows you to zoom in and drill in and go for there, whereas over here you can see top addresses. What's also cool is the ability to add filters. So as opposed to, so a lot of times when you're working with data pipelines and dashboards, you need to do your analysis up front, create specialized views of already pre-calculated stuff. Because thanks to DuckDB, it's now cheap enough and simple enough to do actually something like this, where I can just apply a new filter and it can recalculate all the same metrics in real time. So instead of having to create all these different possibilities, you can just work directly off your raw data set. Great. So that's a little preview of that. So those are the two. Now this is actually a more broader view, which I got to make up with Google Gemini. So this is the more we're going to talk about on the data engineering side. While I just showed you how you can consume data, this is talking about more how you can ingest data, clean it, and make it available for use. So we'll go over this in a little more detail, but a quick start. In general, we're going to be talking about three raw data sources: the NYC Open Data Portal, which you're all familiar with, the Checkbook API, which allows more transaction level details into the city, and the various ad hoc sources, which might be from foils or kind of random city or data drops that don't go to the established channels. From these sources, they're going to be unoptimized formats: CSV, JSON, XML. Instead, we're going to take all that, put it into Parquet files, which I'll talk about in a little bit, which makes it a lot smaller and easier to work with. Then we're going to add some enrichments. We're not just taking the raw data, we're going to improve it. We're going to identify bad columns, bad rows. We're going to be able to add data quality flags, add enhancements to new joins. And lastly, we're going to write it to Duck Lake, which makes it a lot easier to then consume the data later on. I'll talk about that a little later. So before, I want to understand why data engineering is the most important part, and why for any data project, you should start with your data engineering front. In order to do that, I'm going to talk about something that's a little sad for me to talk about: Miami Dolphins football. So for those that don't know, the Miami Dolphins have not won a playoff game since the year 2000. And unfortunately, thanks to my dad, I'm a Dolphins fan. It's a pretty terrible existence, but we can learn from them right now. See, the Dolphins have a consistent theme over the last 20 years or why they always fail. They always go for the flashy solution. You have a star wide receiver, big name free agent. They don't really like to focus on the fundamentals. They never build an offensive line. See, in football, the offensive line is a force multiplier. It allows your running back to have open holes, gives your quarterback time to throw, keeps your defense refreshed. The point of the offensive line is it makes everyone else's life easier. While a lot of teams, they like to go for the flashy solution, you start with the line, you got to see success. That's how the mental model wants you to use for data engineering. So a lot of times you want to do a fancy data solution. You go to fancy BI dashboards, BI app, or you want to jump straight to ML. Ooh, I can use AI, automation. A lot of these flashy tools get you some wins, but without really establishing your offensive line, building your data engineering base, most data applications are going to fail, unfortunately. So let's talk about how I'm building NYC's O-line. First, we're going to go over some of the underlying concepts we see in here and understand why they're so important and why they're so good and why you should be using them. So why working with data is so much easier now? Fundamentally, there's 4 core catalysts that make it so that working with data compared to even just 10 years ago is an entirely different game. Number one, Moore's Law has been happening for the last 2 decades. So even the last 10 years, the computers are just better and cheaper and easier to use. More cores, more RAM. Number 2, we have column-based open data standards, which I'll talk about in a sec. Basically, what these open standards means is, as opposed to being stuck and siloed within tools, there's a single standard we can use to transmit data no matter what we're using that are optimized and really performant. Number 3, modern coding tools of LLMs. So LLMs, obviously, everyone knows. AI is fantastic and makes things easier. But also, modern package managers like UV, Bun, we have things like Podman and Docker. They allow for the deployment of these different kind of like any things into any different cloud with cloud quantification. So you can take the same resource, the same workflow around your computer, you can run it into different competitors. You can run it without having to change your whole software, which allows them to commoditize. They can no longer just trap you, and they have to have to compete on performance and actually providing good services. So now let's talk about the 2 core duos that really allow the whole data space to massively accelerate and go forward. Apache Arrow, Apache Parquet. Think of them as just massively adopted, super performant, open standards. So the mental model to use for Arrow and Parquet is to think of it is they, instead of just storing the data, they store along with the data about the data. So let's look at this. Let's say you had 100 million rows of information, just arbitrary amount. As a CSV or JSON, that same 100 million rows of information might be 10 gigabytes or 100 gigabytes, however many columns you have. However, and it's going to be just that data. But if you then convert that to a Parquet file, that same file might just be 1 gigabyte to 10 gigabytes, 90% lower. Same information, just compressed. In addition, what makes it really cool is it's not just the data. It includes special information about the data so that when you have to actually use it, you can use it a lot faster. Stuff like, what's the actual schema of the underlying data set? What are the min-max of each columns? How was the data organized? By actually having this extra information about it, you can increase, without having to do much work, but just by changing the code you use, save CSV, save Parquet, you instantly get cost savings, performance increases, more reliability. Literally just right out of the box, one change, lots of benefits. So just understand this, I'm not going to go too much. Apache Arrow is the version when you want to use it in memory. So let's say you're using a tool like Pandas, or you're creating a web app and you want to display data and send it to the browser. Arrow is the way to standardize that in memory. It's no matter if you're using Pandas or a tool. Whereas Parquet is when you want to save that data for long-term storage, like on your computer, or in S3, or Google Drive. So Arrow, when you read it, in memory, it's in a process, that's Arrow. When it's saved for long-term, on disk, that's Parquet. Now, I'm not going to go too much. Now, DuckClick and Iceberg is now a way to, once you have a lot of Parquet files, how do you manage those Parquet files? So think of it as a way to, as a manager for your various Parquet files. How does, like, let's say I have an orders thing on S3. And let's say my orders table is made up of 10 files. And let's say, or once a day, I upload a new file to add it to the table. How do I tell my front-end app, hey, I added a new table. This is now what makes up my table, these 11 files. Instead of me manually doing that and tracking it, Duck Lake and Iceberg handle that for you. They kind of track which files are make up what tables. Make it a little easier. You can ask more questions later. I don't go too much into that. So the second thing to understand is, okay, now we have this. We have Polar, we have Parquet and Duck Lake. We've standardized how data is end to end. Now that we have open data standards, we can make it easier to have open engines. So instead of using a data platform like Snowflake or Databricks or BigQuery in order to be able to crunch data, or using Pandas, which would be a little slow, we have these new engines that are natively built for Arrow and Parquet that are really fast. So Polars is what you use if you're kind of more familiar with Pandas and you want to do data wrangling and more code-based data use. So the way it's a very similar data frame API to Pandas, if you're familiar, except everything is just going to run so much faster, especially if you're using a lazy frame, which is basically allowing you to defer execution as opposed to loading everything in memory. Again, if you want to ask questions about that, we can go over it later. DuckDB is for those that prefer SQL, which is the universal language of data in general since the 70s. So DuckDB, instead of having to set up any outside infrastructure or do an entire like table schemas like creation, do a bunch of stuff for setting up a database, DuckDB is just ready to go. Think of it like an engine you can just import to your process and start ripping. It's fast and ready to go. So then once you have this, okay, so you have your standardized data, you have your open engines, great. So now you're doing all this cool stuff of querying and data wrangling. Now you want to start doing stuff over time. How do you organize that? How do you turn a bunch of arbitrary scripts into a pipeline? So that's where Dagster comes in. Dagster, basically think of it as a Pythonic way of adding metadata to your process. So you can have your general, whatever you have for your general Python flow, arbitrary scripts. This just gives you a container to wrap it around. They automatically inherit really cool stuff like pipeline UI, scheduling, logging, having asset integrity, factory formations. Basically, think of Dagster as, oh, I'm doing all this data stuff anyway. Instead of having to recreate the generic parts, I'm just going to inherit it by learning this one interface. Cool. So think of these 3 building blocks. Open standards make it so you're never locked into a particular provider. Your data is always safe and can be interoperable and extremely performant. Open engines means that anyone can, from their computer, query that. You don't have to pay a fee in order to use really good technology to calculate data. And open orchestration means that we can then be able to build on that, add more arbitrary complicated data pipelines without having the complexity overwhelm us. We can let Dagster handle that. Cool. So now let's actually see that in action as opposed to just talking about it. So I'm going to go here. Feel free to follow along if anyone wants to as well. It should be not that hard, but also feel free just to watch. So right now, I'm Git cloning. That's setting up. Cool. So your exact thing might vary depending on what you have installed. But again, if you haven't encountered any problems yourself, just ask the AI to help you debug. It'll be able to figure it out. Cool. So I'm going to start with this. Cool. So this is using UV under the hood, which is similar to pip, but just a lot faster. So now I'm going to, source. Great. Then, great. So in this example kind of repo I've created, I've designed you an already integrated basic data pipeline that's hooked up to the NYC kind of data portal with a few different sample assets in there. So by following the instructions of just install and then make dev, which for those who don't know, make is just a way to have CLIs. If you don't have make installed and you want to run the actual commands, just open the file and check it out. So I'm going to click here. Great. So this is the Dagster UI, which means it allows you to see what you can do. So these are the various different kind of data pipelines that I have set up as examples. So that talk about different assets. So this one's for DSNY tonnage and there. Before I do that, actually, before I forget, let's just start off a few seconds. Hold on. Sorry, this is a thing. Get Copilot out there. No one uses Copilot. Whoops. Just gonna fire these off for the sake of time. That's related. And see with the stem zoom. Okay, great. So now I'll fire this off and just set it up. So what I'm doing here is just for the sake of time, I'm firing this off so they can work in parallel. So great. So now I'm going to come back here. So while they're doing that, I'm going to show you some of these. And so you can go into here and they apply to build a DAG. So, okay, first I'm going to download the raw data, then I'm going to clean it, and then I'm going to join it together over here. And what's also cool about DAGs here is allows you, like I talked about, it allows you to attach metadata. So for example, I can attach the metadata transactions of, oh, this is the data dictionary of what we're going through, including all the columns. Great. So then I'm just going to do this. Let's get all of these going. Great. So what the Dagster, what Materialize Selector does is Dagster makes it a really nice, easy way of just triggering stuff versus random scripts. So if I go over here, I can actually see my run. And by viewing it, I can actually trace and see over time, okay, these are the assets that are working. This is when they come in, it's how long it takes. I get a nice steps, I get logs. I get a nice row accounting that made sure, okay, these were the total number of raw rows I had. These are the total number of clean ones we did. Okay, that worked. That all passed. I can trust that data. Fantastic. So then at the end, it's going to be, instead of just doing it, cool. Now we're going to go here. So now let's analyze the data we just downloaded with our notebook. Cool. That just installed an extra package just for the notebook. So let's query locally. So over here, we can see this is what the clean data we just downloaded. Right now, the Dagster is the code I have is set up so that it's saving the code and data in a repeatable format. So the landing is here and the raw is here. Great. So now you just go do this. Jupyter notebooks are annoying. Come on. Yeah, Jupyter notebooks are really annoying. Damn notebooks. Fantastic. Yeah, notebooks are weird sometimes. So what we just did is we just set up some code, and the notebook is set up so we can now analyze our code that we download here. So you can see these are the different desks we have, and so now we can actually describe one. Cool, this allows us to see our column names, and you can go through and just be able to query it and call in various information. Fantastic. So this is nice for being able to, you have data, you have different stuff you want to do, you want to be able to run a pipeline and then be able to analyze the data you've just created. So these over here are actually more different, whereas opposed to raw data, these are already curated data sets. So run for SQL pipeline. I'll show that in a little bit. So now let's go over here. So now we're going to do this. Let's actually, instead of just using the existing ones, let's create a new one. So let's go to the NYC data portal. And then let's choose a data set. I'm going to choose this one because it's pretty small, and then it's popular. Great. So 404K should be very quick. Great. So what I'm doing here is in Claude, what you basically can do is these skills, which are just think of them as literally writing text that just tells it what you can do and how you can use code. So what I did here is I gave it a code and a script that lets it just scrape by when you pass it a link to a URL on the open data catalog, it'll let you be able to it scrapes it and grabs all the content in order to find the column names, the number of rows outside the gap. Cool. So it just fetched. Great. So it saw the number of that, the columns. Okay, fantastic. So the reason, because it's only 414,000 rows, it's very quick. You can do it in a single, you don't need to do partitioning for that. You can just grab the whole thing in one go. Fantastic. So it did that. It's choosing some names that are mostly clean, a few to normalize, M&A. Okay, so it's also making some suggestions to making it easier for Downstream Analytics to expand some of the names. Okay, great. Okay, yeah, do that. Hold on. Just let me tell it. So that should allow it to be able to just not ask to make permissions every time. So what you can do with Claude is your experience might differ a little bit because of permissions, but I have it set up where I've whitelisted some of these pre-made scripts so that I don't have to keep asking me for stuff. And I trust that it's not going to do anything wrong because the scripts aren't set up to do anything wrong. Great. So then what does that? Cool. So let's come back to that in a few minutes and see how that went. Now let's go over to Query Station over here. Cool. So that's showing you how you can use code to create your own data, ingest it yourself to be able to analyze it. We'll go back to there in a second. But what if you don't want to do that? What if it's like annoying, or especially if you're dealing with some of the bigger data sets that are tens of millions of rows or 100 million rows? What if it's really annoying to maintain a data pipeline for yourself? It is. And also, if you want to go further, which I have. So by using remote mode, I've already run this pipeline myself, saving these assets and making them available. So what does that mean? So if you go to Query Station right now, you'll see the access code. So the access code for crazy Open Data Week code. Crazy spoiler. Great, it worked. So what this does is when you can access remote mode, if anyone who signs up now and if you want to use Open Week code, Open Data Week code, go right ahead. I've only made about 75. Let's see if anyone hits it. So what these are actually curated data sets that I already collected, saved, and enhanced. So you can access from various sources across the environment or for NYC Finance or what have you. So then even though it's 9 million rows, you can instantly start exploring it. And same thing for being able to say revenue. Let's do build revenue. Great. So now despite no matter how big the underlying data set might be, and it really is about the same time to actually work with it in the browser and to explore it, because it's not actually sending this whole 9 million rows to the browser. It's only sending what I need, these 50 rows. So everything is relatively quick. And same thing if you want to be able to query. And then also what's cool is you can actually go in and see some of the stuff that's a little faster. So for the floodnet. Great. If you want to find floodnet, we'll be able to analyze the floodnet and everything you want to. So these are NYC rows that kind of track flooding in New York City. Fantastic. And then last one, if you want to be able to So there's this new really cool thing called Mosaic, which is from the University of Washington, which allow really a way to define visuals and all that. So I already basically just copied this, sent it away just so I could have this set up. Great. So the idea is you can, instead of having you can have a YAML customized way of defining visuals, and then it'll just produce them. Great. So if you want to be able to define visuals and to explore them here, that's a way to do that. Cool. And so that's when we can be able to have it for that. So now let me actually go here. So let's say you still want to use the remote data sets, but you don't want to use the front end. So I'm going to create an API key. I don't care. I'm going to revoke it, and it also who cares. So feel free to use that API key if you want. So then if I go, where am I? Cool. My end file. I'm going to add this here. Great. So now over here at this call that I said I can use the Query Station skill, we're going to come back to him. Great. Now, okay, great. So what I'm actually doing here is, as opposed to this agent that's helping us analyze our rows that are physically on our computer, this one's designed in order to actually access the remote data set. So what it's doing right now is using a different script to make API calls to Query Station in order to access these remote tables. Oh, can't do too many, can't do multiple at once. Oh, that's too bad if it broke. Yeah, these things happen. So over here, okay. Oh, great. So now actually, let me go back here. So it looked like our asset that I create over there, it works. Let me actually just open this back up. I probably should have just done reloads definitions, but it doesn't matter. So let's do this. I bet you I'm gonna set this guy. Great, you analyze it. Let's see if we do that. So over there. So we're gonna come back. So this now in city government. So now this new asset that we had it build, it's here in the UI. So we can go find it. We can see when it ran. We can see what it ran, the logic it did. We can actually grab this nice metadata of the full description. Great, we can check it out. So cool. So now I can go back, be able to see, confirm it. It's in here. Great, there it is. Awesome. Now let's go back over here to this guy. Cool. So this analyst over here is using DuckDB locally to create, once we've already downloaded the data, what information can we pull from it? So now it's actually going ahead and doing that. It's writing its own SQL queries, it's executing them, and then it's going to come back to me and build a report on some of the finding it's made. Let's see what this guy's doing. Okay, great. This guy's doing well. So over here, as opposed to this analyst that was only able to access your local files, this one had the API key from Query Station, which means it allows it to unlock and query all of the data sets we have in the catalog pretty instantly. Millions of rows, which can happen pretty fast. And so now we can say, why don't you... just to keep it consistent. Let's see what he comes up with. Okay, great. Okay, great. So now we can go back over here. So let's see what he came up with. So total listings went up. Oh, that's pretty good. There's a big search over there. We'll have to check the data after this, but he's a good way to start off. Instead of having to go in and do all the initial EDA yourself, have him start off. And we can also do, maybe have this. Great. So now what you can do here is actually say, okay, so now you've taken your report, you've beat some good SQL queries. Now let's save that information. Take those SQL queries and make SQL assets. So over here, SQL assets are basically, you can just define your SQL queries that you want against the table with some extra metadata stuff up here you want to have just to have being able to say different things, and then it'll parse it and be able to do it. So when it adds it, and so then this what allows you to say, okay, once I've downloaded my data, I want to be able to recreate the calculations I have to calculate X per month or Y per year. And so now it's going to do that. It's adding in the SQL queries that it just generated in there. It's going to run them, and then I'll have that. And so then when it finishes up, what we can do now, here it is. Great. So now it's updating, so let's go back over here. Oh no. Rate limited. Should have added more. Things are okay. Okay, so now it's over here. So now I'm going to go back and reload the definitions. Cool. So now we can see we've reloaded. We can actually see that it has actually added all the various SQL queries that created that on analyze things about stuff like that. We can see. We can actually view the SQL queries. Okay, great. So this is the type of stuff great. Now we have that. You have to check it afterwards, so you don't want to just rely on it, but it allows you to massively accelerate the ability to be able to look into that, to analyze things. Cool. Yeah, unfortunately, I did not set the rate limit enough on the thing for apparently, so the query is not going too well. Let's see if the site's broke. No, pretty good. So I guess must just be on the thing. So let me go back over here. Oh, sorry about that. Did not mean to click share. So now why we should understand what some of the differences between the data you can grab yourself versus accessing the already curated version. So in addition to being able to just grab the clean data, what we can do now is to enhance the New York City data. So standardized agency and borough names. Some data sets have all caps or all undercase caps or abbreviations for agencies. Nathan actually himself created a really super helpful standardized agency name data set, which I use as a kind of a source of truth. So every time for every data set, automatically identifies the agency column. Let's create a new clean one. Borough names. Some people like having Manhattan or all caps Manhattan or just a single letter. Again, keep it like that. Flagging bad input rows. So for example, in the 311 request, I believe last I checked, it was, I don't forget the exact number, but it was a lot of there's several thousands of rows where the close date is before the created date. That doesn't make any sense. And so you need to take those bad rows out. And also you have to identify those bad rows, because if you don't, all of the resolution metrics are immediately just completely wrong if you have that negative values in there. And lastly, appending BBLs allow for kind of more consistency. So then there's also analytics improvements where you're actually going beyond that. Crap. And then you're also pre-calculating metrics. So you might want to pre-calculate metrics like, oh, what was actually the closing time, as opposed to on your downstream query calculating for every row, what was the closing time? I just add a row that shows, oh, this amount of resolution time was 2 days or X number of hours. So downstream for analytics, you can just filter directly by that. So then business semantics understanding. So actually, if you go into a lot of these various rows and the actual data sets, like for the budget, especially finance ones, you'll see columns that have hundreds to thousands of different variables, of different inputs they can have. And then when you drill into them, a lot of those are either duplicative, like the same thing, but they're slightly different spelling, or they are abbreviations. And they're just too hard for anyone to be able to have any type of useful analysis for. So when you have bucketing, you want to say, okay, I'm going to take these 10,000 terms and have a semantic understanding. So we're going to bucket them to 15 analytics friendly terms. And then attaching additional domain context. So being able to attach more context to it. So when your DuckDB analyst wants to be able to query it, it can already get the domain explaining the underlying data sets, the notes about it, being able to understand what the laws are around a certain package. So for example, for the city council budget, there's certain laws around what they're allowed to spend that money on. You can now add that context to the agent so it knows to take into account when analyzing the city council budget. So then overall, the NYC data sources that I'm focused on right now are Checkbook NYC, which right now is probably the worst API in terms of easy to use, because it only sends 20,000 rows per call and only XML. Not that big a deal though when you can just parse it into Parquet files. NYC Open Data, anyone can use this themselves now. That code I share is open source, MIT license. If you can use it to now ingest any APIs from Socrata for whatever you want. Whether you care about cars or you care about public safety or crime, you can just go out and get the data. No one's stopping you. And also, if you want to be able to mix it for non-NYC really open data stuff, literally just ask Claude, hey, I have this code base that shows how to grab data from Socrata. Help me with this API source from grabbing it from Shopify or whatever source you want. You're free to mix and match the code. It's open source. Go ahead. And then ad hoc sources that are over time from FOIL requests, or when a city employee, when they need to release data that's not through the normal channels. I'm going to be aggregating all this information and creating a centralized place for people downstream to work with it. Great. And so now these across NYC, there are several different domains across transportation, education, budget, housing, crime, and service environment. Now, right now, when you talk to a lot of people, I see it's a lot of solving of the same problems over and over again. They all have these vastly different things they care about, but at the end of the day, they all have to work with APIs the same way. They all have to grab data in the same way. And it's a very repeatable process. I think what we can do instead is now build on top of data engineering work, where you can trust underlying data and then go from there, be able to focus on more value added. How can you actually connect the code and insights to legislation? So now over here, what I want to do is over time, here's some downstream use cases from having better data engineering. Forecasting, we can better predict our operations. And right now I'm doing mostly historical analytic work. Over time, with a very strong foundation, we can do a collective forecasting, understanding what's going to happen. We can identify trend anomalies. Before something really bad pops up, we can identify it proactively. We can conduct impact analysis. We can understand, okay, when X law went into effect in 2019, what changed? When new law came into effect in 2022, what happened? We can start to formalize these analysis, as opposed to just living in a presentation or a PowerPoint and then dissipating into the ether. We can create reusable code that can be reproducible, audited, and then readily available in an application. We can use the New York City data to train students. There's people that are learning data science every day. Instead of having them all learn on toy data sets, we might as well just have them working with New York City Open Data. Just kill two birds with one stone. Learn how to use data, build a portfolio for yourself, provides public civil service. And training models. Again, over time, we can just keep seeing what works. Use New York City as the training grounds for creating new forecasting models, seeing what works, what doesn't, what tunes matters there. These are all things we can do by working together. Cool. Now, these are 3 ways that I believe I would like to work with the city itself to improve the data upstream. Number 1 is providing access to the data sets as an append-only stream instead of updating. So right now, a lot of New York City data sets, they aren't necessarily like streams where, oh, if I download it at this time, none of the previous rows are going to change. Some of them are update in place, where the same row of information, depending on when you pulled it, might look different. That's really annoying if you're a third-party analyst, because then you have to constantly make sure you're refreshing the entire data set as opposed to just what you missed. If the city was able to actually redesign the data sets to trust the downstream person, where it's saying, hey, these data sets are never going to change. You only need to ingest the new ones. Or if we need to make a change, the new row will be saying that. So as opposed to changing the old one, just create a new row that says, oh, change the old row. It makes it a lot easier for people like myself or anyone who wants to build New York City data to be able to build trusted systems that don't have to be extra complicated rules to maintain. Number 2 is, let's go after the rows that we can programmatically say these are bad. So like I just said, in the 311 data set, there are several thousand rows that have an impossible thing. The close date can't be before the created date. These should just be very clearly taken out. And also there's some in many data sets you encounter, oh, this had 8 rows where the columns were transplaced, so you can't use them. Or, oh, these rows missing a critical identifier, so you can't use an analysis. So usually over time it's annoying, but I can programmatically just spit these out. If there's a way for me to then send it out, there can be a way to systematically clean up the New York City data and make it so I need to have less, anyone else can have less code to have clean data. And thirdly, let's create AI native context for data sets. So right now, actually, New York City does a really pretty good job with the data dictionary. It's a little inconsistent with how they do it. Some open data sets have really well documented. They have notes and the full ones right there. Some of them are bare bones, don't have anything, and only have an Excel notes. Let's just standardize that. And also, ideally, let's do is notes out of Excel. It adds an entire manual effort in order to get the context out of an Excel file. Whereas if you just put all this context of the data dictionary, the additional notes you want to put, the legislation attached to it into a single markdown file, a little copy and pasting, that's going to do probably better for 95% of people's analysis from now forward. You can immediately feed that to an LNOP API. And on my part, it can make it more programmatic. I don't have to do manual double checking of context. Cool. So now let's go back over here. Now, not over the course of this, here's what I'd like to work with in terms of this. Think of me as like an offensive line where I've built like a nice foundation for working New York City data. So if you are a nonprofit who cares, or obviously a group that cares about housing or real estate or the environment, I can help you with that. If you're a New York City agency looking for more transparency or ways to work with data without having to go through a bunch of hoops, hit me up. If you're an ambitious individual who wants to build something cool, hit me up. Community boards, real estate. If you work with New York City and you care about data and you don't want to do a bunch of effort to do the same thing over and over again, you can just come hit me up and work with me. So the flow we want to do it is we're going to establish a policy goal. What do you want to accomplish? And we're going to identify the data sets that hold the information that can help make that point. We're going to ingest, clean, and store them in a way that's reproducible and can be kind of trusted. Then we'll analyze the data. We'll use that to generate a report and tie the findings of that report to direct policy actions and recommendations. And then from the reports, instead of making it just die in the ether, we can then, again, make it reproducible code that anyone can then immediately use, and also applications that people can interact with. An example of that report, if we go back over here, we have this nice report. But while I was busy towing over there talking to you guys, it finished the report, gave me a nice little update on the civil service, and we'll see how that happened. What's going on? Candidate volume doubling in 2025. Interesting. Cool. So we can look at that later. And then from the report, use that as a starting off point to get on more. So that's it. So now if anyone wants to contact me, these are the best ways to do it. And now I'm going to open up the floor for questions.
There's a question here that I saw earlier that was somebody from DCP, from Department of City Planning, was talking about evaluating that their team was choosing between Dagster and Airflow for orchestration pipeline or platform. So I don't know if you evaluated Airflow and can talk about why you chose Dagster instead of Airflow.
So I didn't have experience using Airflow, but so part of it was social proof. People that I follow online, they consistently talk about Dagster, so I usually give it a try. And using Dagster, it was just a very nice experience. I don't have to set up any third-party infrastructure in order to use it. It's just importing Python. It also builds on a lot of like Python native things like Pydantic. And so if you're already doing kind of a data analysis in Python, it's like a really natural fit. And then I've also met the team a little bit, so I was able to do that. So arbitrarily a little bit choosing Dagster, but it's the one I just preferred.
We have a question here from Kieran.
So is it safe to use these open source tools? It's a very similar level of danger you would have otherwise. If it's extremely sensitive, you can always use pin versions. But there's always, with these open source tools, there's always the danger of, oh, what happens if someone pushes bad code? If you just use pin versions and just make sure you don't just arbitrarily download it, it'll be pretty okay. And then for work on your local computer, there's no PII risk. Once you ingest the software, it's just running on a computer. It's just a way to crunch data better. Think of Polars and DuckDB as just software that knows better math than Pandas and like Excel. So for the same amount of information, it crunches data faster. So if you have any PI information, it's actually a great fit because instead of having to worry about, oh, what if I put it in the cloud? You can actually work with millions to tens of millions to hundreds of millions of rows of data just from your local computer. So especially good if you have PI information, I would say.
All right. Yeah. So my question, great talk. Thank you for doing it. You mentioned like when interpreting some of this data, you come across like not large swaths, but parts that are just bad. You mentioned 311 where like the end date's before the start date, and from an analysis standpoint, just excluding that. Is there anything that can be done like at the city level, like either notifying about, hey, there's all this bad data here? Because like maybe it was like a typo, maybe like it was like excluding it seems like we might be missing something if that data was just uploaded incorrectly instead of like actually like fully bad data. Is there any notification process for the city itself that, hey, you have some bad data here?
So I believe right now what you can do is I can email the city and say it. But if there's like a formal way of, oh, for this specific data set, like a form or a way to do it where more formally, like these are the ones, I think it'd be more ad hoc. And that's Nathan wants to correct me there. I believe it's like I'd be hot. So informally, just like, hey, these are the code I ran. These are the drop throws identified. Can you check to make sure that these are in fact bad? But if there's a way to more formalize that, I think that'd be the more goal, and also doing it in a way where it's like an output of like code. Because right now, like I run the code and it detects when there's like bad forms, and then creates a report of which rows were bad. So then in the future, I'll just take that CSV and send it over in an email like, hey, these are the rows identified as being bad.
Let me just add something to that. I think it's a great question. And so you're not wrong about anything you said. There is a contact us form that the open data team does respond. It might take a little while to get a response depending on the workload, but we do respond to everything. So if you find like something that's really an error, we don't actually own the data. We rely on a team. There's more than 100 open data coordinators in all the different agencies that they're publishing the data. So we're publishing what they have. So it can take a while to figure out how to route it. I think there's a broader question here about whether something was just an error or you might not know whether you can take that out or not. And sometimes this sort of like extra context about the data might be included in the data dictionary. But I think there's a lot of work. Somebody was asking if that could be in a structured data. If we can take the Excel files and put them in structured data, like a markdown file or something that includes context about this is why operationally sometimes the close date is before the start date. And these are the edge cases. So that's something that we are looking into. And I think that particularly as people like Christian and other projects are identifying, like doing more systematic analysis and sophisticated analysis of data that's on the open data platform, I would love to explore ways to utilize the gaps that are found into fixing the upstream data sets that are upstream from the open data team that are created by the agencies themselves. No promises about timelines or anything about that, but that's definitely something that we're thinking about and excited about. Sorry to take up a lot of your time there.
I just would say last closing remark would be the code for that I shared in GitHub is open source, licensed at MIT. If you're doing any type of data engineering work in general, you can use it as a template, just have Claude remix and reuse wherever you need. And then if you actually do anything around New York City Open analysis and you're working with New York City Open data, definitely hit me up and let's see if we can collaborate and not repeat the same work.